probably about time we should start this show. What's on tap for today anyway?
I don't know. Inspiration just hasn't struck me yet, I guess.
It's probably about time to start doing that, or do I need to?
Ow. I think I may have hit upon our topic, or it hit me.
Well, and all it took was a ton of them.
Oh, or something like that.
The Homeowner's Handbook was made possible through North Star Comfort Services. For over 65 years, North Star has been helping make more comfortable and energy-efficient living environments for Kansas.
While I may have stumbled into today's topic, we should probably start by describing exactly what it is we'll be talking about. We're talking about masonry, which is the work of a mason.
More helpfully, a mason, historically, is someone that works with stone. Today, we've broadened that term to include other things like brick, concrete, and even glass blocks.
Also, we should mention that we're not talking about the other use of the word mason and masonry, which is, of course, in relating to Freemasons and Freemasonry. Although, you may not be surprised to know there is some correlation between the two terms in their origins.
Right. So let's start at the beginning with stone.
So let's see if we can't track some down.
Stone is our original building product.
Whether we're talking about the pyramids of Egypt, the aqueducts of Rome, or even the castles of medieval Europe, stone not only creates some beautiful structures, but also ones that last a really long time. So to learn more about stone masonry, we're here with Bruce Gilkison of Lusco Brick and Stone. Bruce, how are we doing today?
Very well.
So let's start with the easy ones, like what kind of stone is available today?
Well, there's a lot of stone available. One thing I've learned about stone over the years is that they'll ship stone, marble, a lot of things from pretty much any point on the globe to any other point on the globe. But most of what we deal with is stone that is fairly local.
Okay.
Building stone, landscaping stone. A big segment of the marketplace is going to thin stone now, which can apply in a stucco system. But most of the stone that we sell is going to be regional. A lot of it comes from Oklahoma. A lot of it is limestone that comes from here in the state of Kansas. Okay. There are stones from Colorado and neighboring states.
Now, when someone's looking for stone, then you say that there comes from different areas. Does that, the area causes, I mean, you get different looks or you get different qualities? What?
Sure,
Where are you looking for?
Well, stone is a natural product. I mean, it's been forming in the ground for billions of years, you know, and you dig down and you crack it out and you put it in a wall or so it's kind of what nature gives you, and different deposits, different types of stone, sandstone, limestone. You have marbles and things like that that come from other parts of the globe than around here. But different colors. Some stone, it comes out and you have a natural lamination which gives you certain colors. That's typically sandstone where you have layers that crack out. Limestone is really more of an amorphous formation in the ground that has to be cut out in blocks, and then they'll cut it, split it, tumble it, do various things to give various features to it.
Are there any limitations to which kinds of stone can be used in certain areas? I mean, certain places, like say, is limestone anywhere you want to put it is a great place for it, or?
In certain climates, there are probably some stone. Again, it's a natural product. If you have stone that's from one area and you expose it to freeze thaw in a colder climate, that could be an issue with some stone.
Okay.
But most quarries and most products that we offer are tested and identified as suitable for severe weathering kinds of applications.
Well, and if you're getting the majority local, like regional, then it's probably works in that your regional climate, or
Oh,
not
yeah,
necessarily?
yeah. Again, you create a whole different exposure
So it's
because it's
completely
been in
different.
the ground and now you're exposed
Sure.
to all the stuff
Okay.
on the surface.
No, that makes sense.
But I think you can make a correlation between the local stones and their durability and their natural climate. So,
Are you seeing any trends as far as what people are, going towards, or things that are more popular than others?
well, I tell you, we're seeing a real trend for stone. It seems like, of course, in the building industry and architectural styles, I think you definitely have architectural style
Yeah.
cycles,
Okay.
if you will, kind of like a wide tie or a lapel.
Sure.
But they seem to be a lot longer cycles, fortunately.
Yeah.
But I would say probably in the last, certainly our business in the last probably 15 years, we've seen a pretty steady growth in our stone sales.
I always think of, particularly, here in Wichita, I think of the what's now the historical building downtown
Yes.
as the classic, really Kansas
Yeah.
stonework stuff. But we don't see that though, the full, building stone anymore. Or are you seeing some of that
Well,
too?
you're seeing that. You're talking about the county courthouse or
Yes,
the old
the old-
county, the
the old
historical
courthouse.
museum. Yeah,
Yes.
I'm sure that's native Kansas limestone. I'm not
Yeah.
sure where it came from, but you're seeing things. The new YMCA now that's a
true.
stone facade. That's an interesting product. It's actually a manufactured stone product that comes
Really?
out of Canada.
Is there a benefit to going with manufactured?
Well, manufactured products, you certainly have the consistency that you get from a predictable manufacturing process. When you have a natural stone, you're kind of at the mercy of what nature gives you. In a manufactured process, whether it's a manufactured stone or brick, you're certainly, manufacturing to certain requirements, dimensionally, physical properties. You can do some things in a manufacturing process that nature might not give you.
What is the manufactured stone then made of?
Well, that particular product it's an interesting product. It's a calcium silicate product. And basically it's sand and lime that are formed under, and then pigments for various colors and whatnot. But it's formed under pressure and then it's cured in an autoclave. So it's a very controlled process of manufacturing and gives you, the properties that are desired. And then it's a product that can be cut and shaped into various types of dimensions for architectural application.
As you may or may not remember from your grade school or middle school learning, there are all sorts of kinds of naturally occurring solid aggregates of minerals and mineraloids, rocks, if you really want to get pedestrian about it, that occur anywhere and everywhere. We subclassify them then into 3 different categories: igneous, metamorphic, sedimentary, depending upon their actual characteristics. Hold on. You are not going to spend the 3+ minutes you have talking about the details of each kind of rock, are you? No, but each kind is a little different and therefore has its own uses. Oh, that's okay, I guess. I'm so glad it meets your approval, Mr. I'm too good to come to the classroom. Anyway, granite is an igneous stone. It means it is very hard, but it also means that it's very hard to work with. It's both its biggest benefit and also its biggest disadvantage. Once you can get it used, granite can be very, very useful in places where hard surfaces are needed. Marble is an example of a metamorphic stone. We've seen its uses for hundreds and thousands of years. It can be used as a building substance and for sculpture, so it is malleable enough and flexible enough for a lot of uses. For an example of a sedimentary stone, there's sandstone and limestone, which make good examples for those, and we certainly do see both stones used in modern building. But something to be aware of when using these things is that particularly limestone is very reactive to acid, meaning it's going to burn easily and erode even easier. Marble needs to be sealed to keep it looking nice, otherwise it too is vulnerable to some level of erosion. Granite, its hardiness actually makes it a little bit on the more vulnerable side to cracking when under stress. Plus, the compositions of marble and granite means that sometimes it's difficult to find two pieces that go together like you'd like them to. You'll see instances, of course, where certain veins in certain areas are desirable, consistent looks with one another, but you can take two different marble quarries that have two very different marble results.
Stone may be the oldest building material. I mean, it even has its own age named after it. But brick isn't some Johnny-come-lately.
Unless you call 7500 BC recent, which is roughly the age of the first discovered brick.
Well, and I guess if we're talking about geological age, it would be, which we're not talking about today, so carry on.
The first bricks were dried bricks, made out of earth-bearing clay and then dried in the sun.
Eventually we, and I mean we in a general mankind sense, figured out how to use fire to help speed along the process.
This also means in the New World, bricks could be made just about any time and anywhere. For example, in the New World, they could pretty much start that brick making process as soon as they stepped off the boats.
Yes, so let's go back to Lusco and talk bricks this time. What can you tell us about modern brick? How's it made?
Well, modern brick is made, the fundamentals are the same as ancient brick. Then and today is a fired clay ceramic product.
Okay.
You're digging appropriate kinds of clays or shales out of the ground. You're mixing them into a pliable, formable clay. Just think about the clay that you worked with when you were in grade school.
Right.
So that's kind of the basics of the formation of a brick. There are a lot of ways of forming a brick in molds, extrusion processes today.
Which is more common, a mold or
The
extrusion, or both?
extrusion process is by far where most of the production is. But there are still molded brick that give you certain architectural, texture characteristics and that sort of thing. But basically you're forming it, you're drying it to get all the moisture out, and then you're kiln firing it. Temperatures, most modern kilns are going to fire at the high temperature between 18 and 2200 degrees for a period of time, and then you have your brick. So
Now the different colors and stuff that we see, are those done more cosmetically during the making, or is that just depend on what materials went into it?
yeah, the latter you can certainly do for various types of colors. You can do additives into the clay. There are firing techniques that can give you a range of color, but the basic clays will give you the basic colors, of course. And you have probably most brick production is a naturally occurring red clay, but you will see buff-colored clays, white clays, and just other natural colors. From there, you can blend those clays. You can do additives of manganese or chromite or other things that give you particular colors in particular clays.
Okay.
And then the firing technique.
So where is brick made? I mean, is there essentially, a brick manufacturing facility in every state? Or is it kind of all regional, or where is it mainly made?
Brick is made everywhere. I don't know if every state in the United States has a brick plant, but you will see brick manufacturing from the East Coast to the West Coast. I think generally some of it is our history, and then again just some of the habits of how people build. But probably a strong majority of production of brick in the United States is east of the Mississippi.
Oh, okay.
Brick certainly, and some of the history since World War II, there's been all sorts of new wall systems and facade systems, and there's so many things that are available architecturally that weren't available in another era. So brick was probably used more, both structurally
sure.
and for the facade of a building.
Because there just weren't as many
Yeah,
options.
yeah, and
No, that makes sense.
and you know, the trades and the scale of brick was always something that had a, you hear it referred to as having a very human scale, because it's something that a mason can, you know, do with hand techniques. There are so many mechanical systems now that are used in construction, so.
Part of me also wonders, particularly in more densely packed areas, and again, historically, before we had a lot of, say, sprinkler systems, I wonder if there was some encouragement to use brick so as a fire prevention thing, because it's
Absolutely,
not like a
yeah.
wood structure
good
catches
call.
fire, and brick would, like
Exactly.
in Old Town here, with those warehouses, you know,
Yeah.
the brick warehouse, and it's
Yeah,
We go back
absolutely.
to the three little pigs. I mean, the one that
There you
stayed
go.
standing was the
There you
brick,
go.
right?
Oh yeah, the brick
brick.
industry's used that one quite a bit over the years, believe
You
me.
saw my mom.
There you go.
I relate that
Yep.
to smaller
Yep.
terms.
Yeah, yeah. Thin brick. You asked about thin brick.
Yes.
Thin brick is typically a 1/2 inch material.
Okay.
And it can go in a stucco system, it can go in other kinds of applications that would typically be like tile, wall tile.
Okay.
This product is actually to get the character, and there you can see it. It's a 1/2 inch material. They do a corner return so that you can turn a corner and still it gives you all the appearance of full bed brick, but it's a 1/2 inch material. A lot of thin brick is manufactured as 1/2 inch material, and a lot is cut.
So what is this we're standing on now? Is this brick then?
Yeah, it is. This is a 1/2 inch material. It's, I suppose you could put it into a tile class, but it's a brick dimension. It's textured like paving brick would, but it's a 1/2 inch material that, you know, goes down. And this was essentially a tile installation and grouted with tile grout.
Okay. Well, Bruce, with that, we are off.
Well,
Great to
thank you
meet
very much.
today.
Enjoyed
Thank
having
you.
you. And it's always fun to talk about brick and stone.
It's great information.
Hope you learned something.
I'm sure we did. Thank
Jeff?
you so much.
Thanks for coming.
Thank you. Here's a quick summary of the pros and cons of masonry.
Masonry tends to increase the thermal mass or heat capacity of a building. This is the ability of an object, or building in this case, to absorb thermal radiation and then radiate it back into the environment. Kind of like how a concrete driveway will absorb heat during the summer and stay warm long after the sun has gone down.
Masonry walls are more resistant to debris from hurricanes, tornadoes, or just high winds. Think Three Little Pigs.
Masonry also has a useful life of 500 years or more, which is a lot better than, say, steel or reinforced concrete, which can be 30 to 100 years.
On the other hand, extreme cold or wet weather can actually cause deterioration to the masonry wall surfaces due to frost.
Also, as we learned at Lusco, masonry requires a really good solid foundation for it to last properly. Without it, you will have settling and cracking.
While masonry boasts an impressive amount of compressive strength
That'd be the strength against the vertical loads pushing up and down on it.
versus tensile strength,
That would be the twisting and stretching.
which can be accommodated for as long as we make sure to allow for that.
There's also the matter of making sure when we're talking about a brick wall, we're actually talking about a brick wall.
And what do you mean?
Well, what we call a brick wall in most new construction is actually a brick veneer, meaning it just goes on the outside of the existing wall. While in older construction, particularly what you might find in, say, Old Town here in Wichita, a brick wall is actually an all brick wall.
So what does that mean then for the homeowner?
I think I'll take that one.
Where did you just come from?
Don't get me started.
You see, brick veneer is a nice little way we've designed walls to have brick finishes on the outside and yet still use our standard construction on the inside, standard 2x4 lumber, etc., etc. One of the key things to know about brick, though, is that moisture goes right through it. You spray a brick wall with a garden hose, and if there is sun to drive that moisture, it takes about 30 seconds for that moisture to go from one side of the brick, the outside, to the inside, where we really don't generally want it. That's why you will see brick veneer walls. If you ever check one out while the house is under construction, there should be at least an inch of an airspace between the brick wall and the actual structural wall of the house. It is very important to keep that gap there. In certain areas, actually, you may want to even make that gap a little bigger. The main thing that gap is there for is to give that moisture somewhere to go. Otherwise, it is going to go straight into the house. There are certain cases, some people would say that you put a barrier back there, the weather-resistant barrier, as I believe we discussed at least briefly during the siding episode. But this weather-resistant barrier is not a vapor barrier. It provides what's called a drainage plane, meaning if water gets in there, as in a water form, it just runs right down. All fine and good, except that solar-driven moisture is generally in vapor form. So that water vapor will go through most standard weather-resistant barriers and then into that nice wood siding behind it, or the wood OSB behind it rather, soaking the OSB, and you keep that solar heat out there and keep a high moisture level on the outside through that brick into the wall, can even push more moisture into your house. These problems with moisture can even be further exacerbated if you've used some kind of vapor barrier, vapor retarder on the inside of the house, underneath the sheetrock. Sometimes you may have seen a plastic, what they call in the industry sometimes a visqueen, but more of a 4 mil plastic barrier that does not allow any moisture through it. If you have a lot of moisture coming in and being pushed through the house through the brick veneer and it hitting that plastic, it can cause condensation and can cause a massive water damage just from the water being driven inside by the sun. So to allow for that, to escape these problems, it can be remedied, but you have to build for it. Most brick veneer walls should have what's called a weep hole along the bottom in the mortar to allow the moisture to come down and then go exit the airspace through that hole. There's generally going to be a wick of some sort, a rope type product in that hole as well to keep bugs from crawling into it. Obviously it can't just be a one-way street, it is a two-way street, it's just a hole. Do something in there to prevent the bugs but still allow the moisture to come through. In a more thoroughly designed brick veneer construction, you may even see, and this industry wants more of it done than actually is, an airspace along the top of that to allow the whole area to circulate the air, move the moisture out so there's no problem. Another way, of course, to solve that problem would be on the outside of the house. Instead of using a weather-resistant barrier, you could use some kind of exterior boxing, a foam board product that doesn't allow moisture through it either. Then all of that sun-driven moisture, again, just hits that wall and ropes down. No muss, no fuss, no problem at all. You know, I could have done the thermal mass stuff too.
One of the main green benefits to masonry products is that they have thermal mass capabilities. What this means is that the sun will hit these products and then they can store some of that heat for an extended amount of time. One of the great benefits, of course, to a house in the desert is made out of stone is that stone gets warmed up during the day. Sure, it's can still be relatively cool on the inside during the day, but at night that stone then radiates the heat off and lets it into the home to keep the house at a reasonable temperature much longer. The same thing is true with masonry in use in your modern architecture, and certainly there's some other building materials that make even more use of that, such as concrete block walls. We didn't talk much about concrete today, but it is one of the ways that a concrete block wall can keep a house relatively temperature controlled without sometimes any insulation at all, using that thermal mass. One of the other things about masonry as well, of course, is that it tends to be locally produced, so it makes it a very green feature. It takes a short amount of gas and fumes and whatnot to get it from place of production to the point of being used. The other great thing about masonry as far as the green world goes is that it is a great example of how going green can save you green, and of course that second green being money. What you'll find is that siding has to be painted and repainted every so often. Once you've put brick or stone on the outside of the house, that's the way it's going to look indefinitely. So it may cost a little more maybe at the outset, but it can actually end up saving you a fair amount of money in a house you're going to live at for a long time.
Okay, so with masonry done, now we can get back to our game.
Okay, but this time you're the one with your back against the wall.
Fair enough. All right, go along.
Oh! Maybe we should play something inside for now. I mean, after I finish finding all my pieces.
Well, I hope you've enjoyed this week's Homeowner's Handbook on Masonry. We'll see you next week. So how about some dominoes? Chess? Hungry Hippo?
I'm not sure. We found a Candyland, maybe.
The Homeowner's Handbook was made possible through North Star Comfort Services. For over 65 years, North Star has been helping make more comfortable and energy-efficient living environments for Kansans. For future show ideas or feedback about this episode, please feel free to contact the Homeowner's Handbook. Next time on the Homeowner's Handbook, we'll be discussing insulation, including a tour of how fiberglass insulation is made.
Do you want me to set it
I'm
up?
apparently
All
not a good
reasonable
dancer.
efforts have been made to make the information in this program accurate and up to date.
We're gonna go.
Any errors or omissions are unintended and may be addressed in future programs.
Stone may be the
No houses have been
oldest
harmed in the
building
making of this
material. I mean,
program.
it even has a name. It's